All right. So I want to kind of review this whole Cramer's rule deal. Um, so I just kind of came up with a simpler way of explaining this, and I wanted to share. So we already know in order to use Cramer's rule, we're talking about a system. Here is a system of linear inequalities. The first equation, we label our coefficients as A1, B1. And then with the second equation, we label our coefficients of x and y A2, B2. And then C1 and C2 are just our numbers, right? So we know if we were to write this as a matrix, then this would just be A1, A2, B1, B2, and then we would have our C1, C2 like this. But when we're looking for the determinant, right, just the D, then what we're going to do, of course, we just write the vertical bar to represent determinant. And we're going to just do it of our coefficients A1, B1. So this would be A1, A2, B1, B2. And when we find the determinant, we're taking the left diagonal minus the right diagonal. So A1 times B2 minus B1 times A2. Okay, but when we're finding our dx, right, it's still going to be a 2 by 2 here. But basically, if we're finding dx, that means that we're not writing our what would normally be in our x column. We're not going to write A1, A2. What we're going to replace it with is C1, C2. So this is C1, C2. And then we'll write what's in the y column. So that's B1, B2. And the same thing is going to happen when we're looking at dy, okay? With dy, we're going to eliminate the y column. We're not going to write that, but we are going to write the x column. And then we'll replace the y column with the C1, C2. And then, of course, we'll find our determinant here, determinant, right? And then once we find it and we want to find, let's say, our x value, then what we're going to do is take our dx and divide it by d. To find our y, we're going to take our dy and divide it by d. That summed up the Cramer's rule. Of course, we had an example last night where we did, I think it was 3x minus 5y equals 7 and 12x plus 3y equals 5. And basically, to find our d part, right, we just took our coefficients, so 3, 12, negative 5, 3, right? To find our dx, instead of writing our x column, we would just write in the 7 and 5, but go ahead and write our negative 5 and 3 for the y column. And then for our, let me see, I'll write it above because I'm running out of room. So for our dy, we'll write our x column, which is 3, 12, and replace the y column with the 7, 5. So when we're looking for our determinant, we take our left diagonal, which is 9, minus our right diagonal, which is negative 60. So this will be 69. Here is the left diagonal minus the right diagonal. So that's 15 minus 84, which I believe we said was negative 69. Here is the left diagonal, 21, minus our right diagonal, which is negative 25. So what this ends up being is 46. So to find our x coordinate here, we have to take dx divided by d, which is 46 over 69, which simplifies to 2/3. And then to find our y, we take our dy and divide it by d, which is negative 69 divided by 69, which is negative 1. So that's our solution, or our ordered pair for the system. Okay, at least when we're talking about two variables. Now with a 3 by 3 Cramer's rule, which a couple of students stayed after to note this, but basically what you're going to do is we're working with 3 variables and 3 equations. All right, in this situation, it's still a1x plus b1y plus c1z now is equal to d1. And then the second equation, the coefficients are sub 2. So a2x plus b2y plus c2z is equal to d2. And then a3x plus b3y plus c3z is equal to d3. Okay, but it's the same type of situation, right? So our D is just, we're finding the determinant of the coefficients of our variables. So that's A1, A2, A3, B1, B2, B3, and then C1, C2, C3. Right? We're finding the determinant of this. And the way we do it, or the way I taught it last night, was to take these first 2 columns and write them on the outside. And then you're going to take the left diagonal. It's more than one, so diagonals. And then you're going to subtract them from the right diagonals. Okay. And there we go. That is the plan. Now, that's just to find D. If we want to find our dx, for instance, let's see if I can fit it here. To find dx, right, same type of thing as we did with the 2 by 2. We're not going to write the x column. We're going to replace that x column with d1, d2, d3. And then we'll fill in the others as is. So then that would be b1, b2, b3, and c1, c2, c3. Right? So if we want to find our x coordinate, we would take our dx and divide it by our d. Right? And then if we want to find our y, which we could do our dy as well, but that means we would be replacing the y column with the d1, d2, d3, and we would leave the x column as is. So that'd be a1, a2, a3. Replace the y column with d1, d2, d3, and then here we go. This next example we're going into is going to ask us for our y, to solve for y. And in that case, we need dy over d. Okay. This is the example we did last night, where basically it said to solve for y using Cramer's rule. And we were given x plus y plus z equals negative 5, 2x minus 3y, minus z equals 40, and x minus y plus z equals 7. All right, so we're looking at this example here where we were to solve for y. And what we're going to do, or what we can do, is go ahead and make this into its own matrix. So it would be the coefficient of x, so 1, 2, 1. The coefficient of y would be 1, negative 3, negative 1. And the coefficient of z is 1, negative 1, 1. And then we draw a vertical bar, and we would do our answers: negative 5, 47, right? And if we know we want to find our y here, then that means y is equal to dy over d. So let's go ahead and realize that our d would be, we're finding the determinant of our coefficients. So that would be 1, 1, 1, 2, -3, -1, 1, -1, 1, right? So we would need to find the determinant of this. Don't forget the first two columns we write again on the outside, right? And then from here, what we're going to take is the left diagonals and add them up. And then subtract it from the right diagonals, right? So that's our D. So that would be, let's see, 1 times -3 times 1 is -3. 1 times -1 times 1 is -1. And -1 times 2 times 1 is -2. And we're going to subtract the right diagonals, the sum of them. So that would be 1 times -3 times 1, which is -3. -1 times -1 times 1 is 1. 1 times 2 times 1. Am I missing anything there? I think that is 2. Yep. And so this comes out to be 0, while this comes out to be -6. And we're subtracting, but it's just 0. So our answer here is just -6, at least for the D, right? This is the D part. So that's our D. Now we have to find our dy. Remember dy, in order to find it, we're going to have our x column as the same, 1, 2, 1, right? Our y column is the one that's going to be replaced by the -5, 40, and 7. So x column stays the same. The z column stays the same, but the one with the y column changes to -5, 40, and 7. And so that's 1, -1, 1, right? And so if we're doing this, going to find the determinant, we can just rewrite, right, the column. So we're going to take our left diagonal, forgot to do the colors, so I do apologize, and subtract it from the right diagonal. So that would be, let's see, 40. -5 times -1 times 1 would be +5. 7 times 2 times 1, I believe that's 14. And then we're going to subtract the right diagonals, or the sum of the right diagonals. So that would be 40 plus -7 plus -10. So this would be 59 minus I believe that's 23. And so we have 36 for our dy. Now, if we're finding y, don't forget we're taking dy, dividing it by d. Since our dy is 36, and our d we already came up with was -6, our y is equal to -6. And this is our answer, and we're done with the problem.